The night pulled a hush over the tundra, and then the sky began to breathe. Ribbons of neon green unfurling against the stars like some slow, living aurora. If you've ever watched that motion and felt both infinitesimal and strangely at home, you've met one of nature's oldest performances, the Aurora Borealis. It starts upstream at the sun. Streams of charged particles, electrons and protons, erupt from solar storms and race across space, slamming into Earth's magnetic field. Space physicists liken the magnetosphere to a giant elastic band. When it snaps and reconnects, energy cascades along field lines and drives particles down into the upper atmosphere. There they collide with oxygen and nitrogen, each smash producing light. The familiar green is oxygen at roughly 100 kilometers up. Reds bloom higher still, while blues and purples trace nitrogen's signatures. That simple chemistry gives us the most complex light show on the planet. Seeing an aurora is sensory, but it's also scientific. Satellites and ground arrays have mapped the dance for decades, revealing that auroras are not just pretty curtains, but indicators of space weather. Surprising to many, auroras can occur over other planets. Jupiter's are far more violent, driven by its intense magnetic environment and the volcanic moon Io. Back on Earth, researchers use satellites like DSCOVR and probes that study the sun to forecast geomagnetic storms, turning wonder into data that helps communities prepare. There's mystery too. People in northern towns have reported faint crackling or rustling during strong displays, a phenomenon still debated by experts. Some studies capture tiny acoustic signatures linked to rapid electric field changes near the ground. Others caution that perception and conditions play a role. This interplay between lived experience and instrumented measurement is what makes aurora science so human. Part spectacle, part puzzle. Today the aurora matters in ways our ancestors could never have imagined. Power grids, aviation routes, and satellites are vulnerable to the same storms that paint the sky. As our technological footprint grows, so does our exposure to space weather. Forecasting has practical stakes and ethical ones. How do we balance tourism, indigenous territories, and infrastructure resilience when the heavens grow more active? Scientists are racing not only to predict auroras, but to protect the systems that depend on a calm ionosphere. When the curtains finally fold and the lights slip away, what remains is a quiet invitation to wonder, to learn, and to respect the invisible forces that connect Earth to the sun. If this short journey through science and sky struck a chord, please like, share, and subscribe for more long-form explorations that look up, dig deeper, and keep asking why.